Okay, so think about the last app you used on your phone, maybe to order some food, chat with a friend, or, I don't know, check the weather. Behind that simple, clean screen is this massive, carefully constructed world. Today, we're going to pull back the curtain on that world: software engineering. So, how does that little spark of an idea turn into a polished, working product right in your hands? It's not just about late nights and energy drinks and endless lines of code. It's actually a really disciplined process, and it all starts with a simple but super crucial distinction. So, on one side, you've got the raw engine, a program. It's really just a set of instructions that does a thing. But on the other side, you have the finished car, a software product. That's the whole package, the code, sure, but also the user manual, the support, the licensing, everything that makes it ready for you to actually use. It's kind of like the difference between a recipe and a fully cooked meal delivered right to your door. And the bridge that gets us from that raw code to a reliable finished product, well, that's software engineering. You should really think of it like civil engineering, but for the digital world. I mean, you wouldn't build a skyscraper without a detailed blueprint, right? Well, you don't build a massive app without a formal structured process either. Okay, so what are the core rules of this digital construction site? What are the fundamental principles that keep these incredibly complex projects from just, well, falling apart? To prevent total chaos, engineers live by a few key ideas. Modularity, for instance, is like using Lego bricks instead of one giant block of clay. It lets you work on different pieces independently. Reusability means, hey, if you build a really great Lego wheel, you can use it on any car you build later on. But maybe the most powerful idea of them all is something called abstraction. Abstraction is all about hiding the messy details. To drive a car, you just need to know how to use the steering wheel and the pedals. You don't need to understand the thousands of moving parts under the hood. In software, this is absolutely critical. It lets one team build a super complex feature without every other team needing to understand exactly how it works. Okay, so we've got the guiding principles, but how do you actually apply them day to day on a real project? For that, you need a playbook, a shared strategy that the entire team can follow. Because without a plan, you get exactly what the slide says: chaos. Deadlines get blown, budgets spiral completely out of control, and worst of all, the thing you build doesn't even solve the user's problem. That's precisely why the industry created a structured playbook. And that playbook is called the Software Development Lifecycle, or SDLC for short. Just think of it as the master roadmap. It's the guide that takes the software project from the very first conversation all the way to its final release and everything that comes after. Now, the SDLC is generally broken down into 6 core stages. And to make this really easy to understand, let's just use the analogy of building a house. It actually follows a very similar and very logical progression. Stage 1 is all about planning. Before you even think about breaking ground, you have to ask the big questions. Can we even build this? Can we afford it? And maybe most importantly, will people actually use it? This is all about answering the big what and why before anyone writes a single line of code. So once the vision is set, it's time to get into the nitty-gritty details. Every single button, every feature, every little behavior is documented in what's called a Software Requirement Specification, or SRS. This document becomes the project's Bible. It is the single source of truth that everyone on the team agrees to follow. With all those requirements locked in, the architects step in. This is where they drop the technical blueprints. You know, how the database is going to work, how different parts of the app will talk to each other. They're laying out the entire structure before the first digital brick is laid. And this is the phase that most people think of when they hear software development. It's the construction site. The developers take those design documents and start writing the actual code, laying the digital foundation and building the structure, piece by piece. You wouldn't move into a new house without a thorough inspection, would you? Of course not. And that's exactly what the quality assurance, or QA, team does here. Their job is to try and break everything. They hunt for every bug and glitch with one simple goal: find the problems before the customer does. And then finally, it's launch day. The software goes live for everyone to use. But you know what? The work is never really over. This final stage is all about deployment and then maintenance, fixing bugs that pop up later, adding new features, and basically being the building superintendent, fixing that leaky roof a year down the road. So who are all the people on this digital construction crew? Well, it's not just one type of builder. The team is actually incredibly diverse, with a specialist for every single stage we just walked through. You've got front-end developers. Think of them as the interior designers who build everything you actually see and interact with. Then you have back-end developers, who are like the engineers managing the plumbing and electricity behind the walls, the servers and databases. You have the QA engineers, who are our inspectors, and DevOps engineers, who are kind of like the logistics team, making sure the final product gets out the door smoothly and stays running. It's a huge collaborative effort. So we have the principles, the playbook, and the players. But how does this all actually work in the real world, where things are constantly changing? Well, it turns out the playbook itself has to be flexible. Because here's the thing, that rigid step by step build a house model doesn't always work. Sometimes you're not building a house, you're trying to navigate a twisting river in a canoe. The SDLC is a framework, not a set of concrete rules, and different journeys require different kinds of boats. This slide shows the two main philosophies perfectly. On the left, you've got Waterfall. That's where you finish each step completely before moving to the next, like building a house floor by floor. It's pretty rigid, and making changes late in the game is super expensive. On the right, you have Agile. That's all about working in small, fast cycles, getting constant feedback, and being able to change direction on a dime. It's much more like sailing than construction. And this playbook is always evolving. The latest chapter is something called DevSecOps. The big idea here is that security can't just be an afterthought, like a final inspection. It has to be part of the process from day one. It's like building security cameras and strong locks right into the original blueprint, not just hiring a security guard after the house is already built. So, from these core principles to these evolving playbooks, software engineering isn't just about writing code, it's about process.